What if I told you that one groundbreaking AI costs just a fraction of another to train, yet delivers comparable results? On one side, we have Deepseek V3, an advanced AI model with a training cost of just $5.5 million. On the other, there's OpenAI's GPT-4o, which comes with a massive price tag of over $100 million. Despite the significant difference in cost, these two models are highly competitive in terms of performance. So, how does DeepSeek manage to keep costs so low while achieving top-tier results? In this video, we'll break down the key factors that contribute to this price discrepancy and reveal why Deepseek V3's approach is revolutionizing the AI space. The two models. To begin, let's take a closer look at the two models involved in this comparison: Deepseek V3 and GPT-4o. Deepseek V3 operates on a modular design using a mixture of experts, a MOE architecture. This setup allows it to activate only relevant parameters for each training step, minimizing unnecessary computation. The model is trained for 57 days using 2,048 NVIDIA H800 GPUs, processing 14.8 trillion tokens of data. With a total cost of just $5.5 million, Deepseek V3 is highly efficient. On the other hand, GPT-4o employs a dense architecture, meaning it activates all 1.8 trillion parameters during training. This structure requires an enormous amount of computational power, reflected in its high training cost of over $100 million. GPT-4o is trained for 90 to 100 days using 25,000 NVIDIA A100 GPUs, processing a slightly smaller dataset of 13 trillion tokens. Despite the longer training time and higher cost, GPT-4o delivers extraordinary results, making it a powerful tool in the AI landscape. Architecture and design. One of the primary reasons for the cost difference between these models lies in their architecture and design. DeepSeek's modular structure and mixture of experts, or MOE, approach allow it to activate only the relevant parameters for each token it processes, significantly reducing the computational load. This means that at any given moment, DeepSeek activates approximately 37 billion parameters per token, as opposed to activating all the parameters at once. This focused use of resources reduces both time and costs. In contrast, GPT-4o uses a dense architecture that requires all 1.8 trillion parameters to be activated for every token processed. While this gives GPT-4o the flexibility to handle a wide range of tasks, it also demands far more computational power. Every training cycle requires the full use of all parameters, making the training process much more resource-intensive, time-consuming, and costly. Data optimization. Another major factor contributing to the cost difference is how each model handles data. Deepseek V3 processes a slightly larger dataset, 14.8 trillion tokens, but it does so with carefully curated and high-value datasets, as well as synthetic data. This allows DeepSeek to make the most out of its training data, ensuring that the computational resources are used efficiently. The model can process the data in a way that minimizes unnecessary overhead and accelerates training time, keeping both costs and energy consumption low. GPT-4o, however, relies on a brute force approach by processing 13 trillion tokens, often using raw, uncurated data in massive volumes. While the sheer amount of data helps the model achieve generalization and versatility, it also places a significant computational burden on the system. The massive dataset increases both the time required for processing and the associated costs, as more GPUs and energy are needed to handle the large scale of data. Hardware utilization. The hardware used to train these models plays a crucial role in determining their overall cost. Deepseek V3 is trained on NVIDIA H800 GPUs, which are considered mid-tier in terms of performance, but are well suited for the type of training DeepSeek requires. These GPUs are optimized for DeepSeek's modular architecture, allowing the model to train efficiently while using fewer resources compared to more powerful alternatives. The use of a distributed network of GPUs further reduces the overall cost, making DeepSeek's training process more affordable and faster. In contrast, GPT-4o relies on 25,000 NVIDIA A100 GPUs, which are top of the line in terms of processing power. These GPUs are specifically designed for the demands of large-scale AI models, and while they are incredibly powerful, they come with a hefty price tag. The high-end GPUs require a more extensive network of infrastructure, including more power, cooling, and space, all of which increase operational costs. The use of such a large number of high-performance GPUs results in longer training times and higher costs, contributing to GPT-4o's significant price tag. Training techniques. Training techniques also play a role in the disparity between Deepseek V3 and GPT-4o. Deepseek employs mixed precision training and gradient accumulation to optimize its training process. Mixed precision training allows the model to use both lower and higher precision formats, which reduces memory usage and computational requirements. Gradient accumulation enables Deepseek to stabilize the training process and update the model less frequently, further minimizing resource consumption and accelerating training times. GPT-4o, by contrast, likely uses traditional training methods that involve processing gradients across all parameters without the same level of optimization. While effective, this approach requires more frequent updates and higher computational power, making it less efficient and more costly. The lack of mixed precision training and gradient accumulation means that GPT-4o's training is inherently more resource-intensive. Energy and infrastructure. Energy consumption is another area where the two models differ. Deepseek V3 is designed to be energy efficient, with algorithms optimized to minimize power usage during training. Additionally, Deepseek takes advantage of cost-effective regional data centers, which further reduces the overall infrastructure costs. By focusing on energy efficiency and strategically locating its data centers, Deepseek is able to keep operational costs low, making the model more affordable to train. GPT-4o, however, requires much more energy to train, primarily due to its centralized training infrastructure and extensive use of high-performance GPUs. The large-scale data centers needed to handle the training of GPT-4o consume significant amounts of power, resulting in higher operational costs. The combination of high-end hardware and centralized infrastructure makes GPT-4o's training process far more energy-intensive, adding another layer of expense to the project. Adaptability and fine-tuning. Another important difference lies in how the two models handle adaptability and fine-tuning. Deepseek V3 is built with adaptive learning in mind, allowing the model to fine-tune its performance in real-world applications without requiring extensive retraining. This means that Deepseek can be continuously updated and improved without undergoing costly and time-consuming retraining cycles. In contrast, GPT-4o requires more extensive retraining to adapt to new data or tasks. This results in longer training periods and higher costs, as the model must be retrained from scratch or undergo significant reoptimization. While GPT-4o's adaptability is impressive, the need for frequent retraining adds to both the time and financial costs of the model. In conclusion, the key factors driving the significant cost difference between Deepseek V3 and GPT-4o are their architecture, data optimization, hardware utilization, training techniques, energy efficiency, and adaptability. Deepseek V3's modular design and mixture of experts architecture, combined with its efficient data handling and use of mid-tier GPUs, allow it to achieve remarkable performance at a fraction of the cost of GPT-4o. The mixed precision training, gradient accumulation, and energy-efficient infrastructure further contribute to its affordability, enabling organizations of all sizes to access cutting-edge AI technology. Deepseek V3's efficiency and affordability are a testament to the potential for more accessible AI technology in the future. With reduced costs and faster training times, Deepseek is helping to shape the future of AI in a way that allows smaller organizations and startups to compete with larger, better-funded entities. If you enjoyed this video, make sure to subscribe to this channel for more content. Thank you.